Hello, my dear students. Let us take one more example on columns and struts. Take this example. A hollow cast iron circular column is 7.5 meter long and is pinned at its both ends. The inner diameter of the column is 160 mm and thickness of the wall is 20 mm. Find the safe compressive load by Euler's and Rankine's formula using factor of safety of 5. Take yield stress sigma c is equal to 550 Newton per millimeter square and Rankine's constant alpha is equal to 1 divided by 1600 and E is equal to 8 into 10 raised to 4 Newton per millimeter square. Okay, what is given here? The length is given and this is a circular column. Length is 7.5 meter long. Okay, and it is pinned at its both the ends, means it is hinged at its both the ends, so L effective is equal to L only. Then inner diameter of the column is 160, so DI is equal to 160 mm and thickness of the wall is 20 mm. So you have to find the outer diameter. How you can find the outer diameter? Outer diameter, let us represent it by D naught is equal to DI plus 2T. Last class I have explained why this is DI plus 2T, because you know that it is a circular hollow section. How it is like this circle, I mean here like this. So this is capital D, right? This is capital D. Okay, this is capital D. How you will get this distance? This is small d. Okay, this is small d and this is thickness. Okay, here both the sides there is a thickness, so it is small d plus 2 times of t. So you get the inner diameter is 160 plus 2 into thickness is 20 meters, so you get 200 mm. Next we'll calculate first area of the cross section. What is that? It is a circular hollow section, so A is equal to pi divided by 4 into D naught square minus DI square is equal to, substitute the values, pi divided by 4 into capital D, that is 200 square, or D naught is equal to 200 square minus DI square, that is 160 mm square. So you get this area. Next find the moment of inertia. Here I that is equal to pi divided by 64 into d naught 4 minus di to the power 4. Okay, substitute the values. D naught is 200 and di is equal to 160. So simplify this, you get 4.637 into 10 raised to 7 millimeter 4. Okay, here it is a hollow circular column, so Ixx is equal to Iyy. Okay. Now, what you have to calculate? You have to find the safe compressive load by both Euler's and Rankine's formula. So Rankine formula requires K. So how you can calculate K? K is equal to square root of I divided by A. So what is I? I is this value. Substitute, divided by A. Area is this. So you get 64.03. That is least radius of gyration K. And effective length also we want to find the slenderness ratio. That is L here. Both the ends are pinned, means hinged. So L effective is equal to L. So that is equal to 7.5 meter or 7500 mm. Now you can calculate what is slenderness ratio. Slenderness ratio is equal to L divided by K. L is equal to, or LE divided by K. Okay, this is effective length. You can take it as capital L or LE. Okay, 7500 divided by K is 64.03. You get 117.133 mm. This is slenderness ratio. Now you can calculate what is Rankine's load first. Then you can find Rankine's safe load. What is the formula? Rankine's critical load is given by sigma C into A divided by 1 plus alpha into LE divided by K whole square. So sigma C is given 550 into A, it is calculated value, divided by 1 plus alpha is given, and LE divided by K, that is slenderness ratio, is equal to 117.133 whole square. So you get 649.64 kilonewton. You have to calculate safe load. How can calculate safe load? Rankine's critical load divided by factor of safety, that gives safe load. So Rankine's critical load is 649.64 divided by 5, factor of safety, that is equal to 129.928 kilonewton. Now we'll use Euler's formula to find the critical load or crippling load, that is PE is equal to, this is PE, okay, and this is PR, you can say Rankine's law. So formula is pi square EI divided by LE square here. This is, substitute the values what you have, that is pi square into E is given 8 into 10 raised to 4 into I is calculated value 4.637 into 10 raised to 7. So you get divided by LE square 7500 whole square. So you get 650.885 kilonewton. Okay. Now you have to find the safe load, Euler's safe load, that is nothing but Euler's critical load or Euler's crippling load divided by factor of safety. So that is, a critical load is 650.885 divided by factor of safety 5. You get 130 kilonewton. Almost same here. This is exactly same, Rankine's safe load and Euler's safe load. So in this way you can calculate what is the safe load by using both Rankine's and Euler's formula. Let us take one more example. A hollow circular section 4 meter long is fixed at both the ends and carry an safe load of 500 kilonewton. The inner diameter of column is 0.8 times the external diameter. Take yield stress as 550 MPa. Factor of safety is equal to 2.5 and Rankine's constant alpha, A or alpha, is equal to 1 divided by 1600. Find the diameter of the column. Here you have to find the diameter of the column. Here what it is given, inner diameter of the column is 0.8 times the external diameter. So inner diameter di is equal to 0.8 times of external diameter d naught. The length of the column is 4 meter or 4000 millimeter or 4 into 10 raised to 3 millimeter, and yield stress is 550 MPa or 550 Newton per millimeter square, and Rankine's constant alpha is equal to 1 divided by 1600, and safe load is given, it is 500 kilonewton. What we have to do first, we will calculate the area. Okay, here we have to use Rankine's formula. So Rankine's formula, we required both A and I. So let us calculate first A. A is equal to 5 divided by 4. This is a hollow circular section. 5 divided by 4 into d naught square minus di square. So pi divided by 4. We don't know what is external diameter. It is not given. So let it be d naught square minus what is di square. Here di is equal to 0.8 times of d naught square, d naught. Okay, so you have to substitute that. So what it becomes, square it is di square. So 0.8 square d naught square or 0.8 d naught whole square. So that is equal to, you simplify this, both are unknowns, same unknown, only one unknown, d naught. So you get 0.283 d naught square. Okay, so just remember you have to square both 0.8 also, d naught also, or 0.8 d naught whole square. That is the meaning. Okay, now we'll calculate I. What is I? I is equal to pi divided by 64 into d naught 4 minus di raised to the power 4. Substitute the values. Again, we don't know what is d naught. So let it be d naught 4 only minus d naught to the power 4 minus what is di? Di is zero point 0.8 times of d naught. So substitute 0.8 raised to the power 4 into d naught raised to the power 4. So simplify this, only one unknown. So you get 0.029 d naught to the power 4. Here it is a circular section, so Ixx is equal to Iyy. So no need to calculate again what is Iyy. Next, let us calculate least radius of gyration, that is k, is equal to square root of I divided by a. What is I? I is equal to, substitute like this only, 0.029 d naught raised to power 4 divided by 0.283 d naught to the power 2 d naught square. Simplify this, d naught square to the power 4 divided by d naught square, it becomes d naught square. Okay, when you take the square root, it becomes d naught. And if you simplify this, 0.029 divided by 0.283, you get 0.32 d naught. Okay, now you know Rankine's safe load, that is nothing but Rankine's crippling load divided by factor of safety. We have Rankine's safe load that is given here, that is 550 kilonewton. Substitute is equal to Rankine's crippling load, we don't know, so let it be PR or PCR divided by factor of safety, it is given 2.5. Substitute 2.5 and simplify this. PCR is equal to 500 into 2.5. Cross multiply. So you get 1250 kilonewton or 1.25 into 10 raised to 6 Newton. This is the first step. After this, what you have to calculate? You have to calculate the diameters, both external diameter as well as internal diameter. How you can calculate? We have equivalent length of the column, that is LE is equal to, here both the ends are fixed, so LE is equal to L divided by 2. What is L? L is equal to 4000 divided by 2 is equal to 2000 mm. Now use the formula, Rankine's load PCR is equal to sigma C into A divided by 1 plus alpha into LE. It is, wherever capital L is there, just change it to LE divided by K whole square. Substitute the values. PCR is 1.25 into 10 raised to 6 equal to 550 into area is 0.283 d naught square divided by 1 plus 1 divided by 1600 alpha into LE is 2000 divided by K is 0.32 d naught to the whole to the power 4. How you can simplify this? 1.25 into 10 raised to 6 divided by 550 into 0.283. You get this value 8030.84 is equal to, now only d naught square is there, divided by 1 plus, multiply these two things here, 2000 whole square, so it becomes 44 into 10 raised to 6. Simplify this, okay, multiplied by this 1600, you get this value. Okay, once if you get this, take the LCM of this, so that is d naught square divided plus 24414.06. Now take cross multiply, you get d naught square into d naught square, that becomes d naught to the power 4 is equal to this equation. Now what you can do, you can take d naught square is equal to x. Okay, write that equation, so that is ax square minus bx plus c. Use that equation and write. Okay, here x square d naught square, so 4, so d naught square is equal to x, so this is d naught square to the square power 2, so that becomes x square minus 8030.84, d naught square is equal to x, substitute, minus 1.96 into 10 raised to 8 is equal to 0. So use this formula, minus b plus or minus b square minus 4ac divided by 2a, or you can use directly the calculator and you find this value. So there are both plus and minus value. Take the positive value, so you get x is equal to 18580. What x? X is equal to d naught square. So whatever the value you get, that is d naught square. So take the square root of that, you get 136.3 mm. This is d naught. Okay, outer diameter. How we can calculate it? calculate inner diameter. Inner diameter is equal to 0.8 times of outer diameter. Here it is given. Okay. So 0.8 into 136.3, you get 109.05. Like this, you can calculate what is external diameter and what is inner diameter. So here you need little practice, then only you will get the correct answer. Thank you.